everybody. Today I am very excited to talk about refactoring our code bases with Angular. I'll be sharing some general refactoring strategies and how we can utilize the latest Angular features to help us on that journey. The title of my talk is called Harnessing Angular's Momentum, Strategies for Effective Refactoring. Before we dive in, let me quickly introduce myself. My name is Anthony Scardapane. I am a senior software engineer at Cisco, and I really have a genuine enthusiasm for writing code that's not only efficient and maintainable, but also enjoyable to work with. In all my years of developing with Angular, I've never been more excited than I am right now about the current state of the framework. Round of applause for Angular and the whole team. Yeah. Angular has indeed been busy. With its recent updates, particularly versions 16 and 17, Angular has rolled out a ton of new enhancements, from standalone components and signal-based reactivity to optimized image handling, deferrable views, and control flow. These features not only boost our application's performance, but also open up new avenues for us to optimize and refine our current projects. As exciting as these developments are, they also bring forth a challenge. Where do we begin? How can we tailor these new Angular features to meet the needs of our current projects? How do we focus on code changes that maximize the greatest value and impact? And importantly, man, this clicker is a little, sorry about that. And importantly, how can we optimize the integration of all this new stuff into our current code? But wait. First, we need something. It's essential to understand that just knowing about these features isn't quite enough. There's a foundational step that we must take before leveraging all these new advancements. Strategies for effective refactoring. These strategies will kind of serve as our compass, guiding us through the process of enhancing our applications with Angular and ensuring that we not only improve our code, but we do so in a way that's maintainable, scalable, performant, and team-friendly. Let's start off with a definition of refactoring as I tailored it slightly to the context of this talk. Right, so we're talking about streamlining and upgrading our Angular code using the newest advancements while maintaining its fundamental functionality. Right, our aim is to create readable, maintainable code that's not only easier to work with, but is capitalizing on all the efficiencies and capabilities that the Angular team continues to pump out. So what is my first strategy here is to learn. I think the cornerstone of any successful refactoring journey or update is to learn, right? Not only does this help us stay up to date on the ever-evolving world of front-end development as a whole, and specifically Angular, but I think it just makes us more skillful engineers. It's not just about reading documentation or following tutorials. I believe hands-on experimentation really wins at the end of the day with how we could best integrate some of these things. Building mini projects, implementing examples of new features. Check out the Angular playground at angular.dev. It's the awesome new site that was already plugged a bunch of times. It's really cool for just getting a little sandbox environment to test out features, right? Read code on GitHub. We basically have a free library card to this plethora of information that the brilliant people in this room and all over the world just publicly share. And sometimes I personally forget that as a resource, how do I want to implement this new feature? Well, I could see how a lot of other people in the community have done it. Right? And lastly, just engage with the community, share knowledge and experiences, and teach other people on your team. I think all of these are great ways to just lock in this foundational knowledge. Another one, before we can really, basically one more thing that we want to learn to be as efficient and productive as possible in our refactoring journeys and our updates is to also learn our projects. Right? We should be understanding our core user flows, determining our critical paths, whether this be from metrics or just familiarity with the applications. Participating in peer programming, right? I always like to say, I'd like to steal knowledge from all the people in my workplace that just know more things than me, whether this is project specific or whether about the language or framework itself, and spread that knowledge. Also, looking into the history of our code really can give us an understanding of where it's been and how it's progressed over time. And sometimes it's a potential way we could say, oh, there's a lot of changes in this one section. Maybe we should look at ways to abstract that, or maybe we should look at ways to improve the stability there. So why is this such important? Why is this strategy number one? I really feel like understanding the features of the framework will reveal opportunities for their application. It's kind of like having a map in a treasure hunt, right? If we know the terrain and we know the hills and the shortcuts and the hidden paths, it's going to give us a greater chance of finding that treasure. And similarly, in our journey with Angular, the deep dive into learning all these features isn't just for academic purposes, but it's practical, right? It equips us with the insight to spot these opportunities where a specific Angular might be just what we need. Strategy number 2 is to streamline with simplicity. Right? We're aiming for simple, clear code that's performant and not a burden to change or test. I used to think that simple meant that anyone could understand it, right? Everyone says, you should write code that anyone could understand. And especially in my early days, I always thought that if I was reading code that was, to me, seemingly complex, that meant that it just wasn't simple enough and they did a bad job, right? And I think over the time that I've learned that when I say simple, I quite literally mean like the opposite of entangled, right? We're trying to like disentangle things together so that they're easier to test, easier to reason about, they're easy to make changes to without impacting our entire application. So what are some of the ways that we could streamline with simplicity? I believe preserving the integrity of data is super important. Data drives the core of our application, and treating it with respect, it's just going to help reduce bugs and follow yes. Sorry about that. We're going to also talk about how we can remain flexible with composability, right? Using composable elements for flexible growth. Embracing functions. Functions are amazing. We could be using well-named functions to create that composability and really get this reusability around the app that we could then easily follow through, easier to debug, easier to just encapsulate some logic that we know that we could change and not have to worry about, oh, this is impacting 500 other things because it's so entangled. And that kind of follows through into creating thoughtful abstractions. We want to not have tiny little abstractions or overly abstract things early on, but making sure that they're just thoughtful and considered, because sometimes we just fall into this complex code pitfall. So what are some of the ways that Angular is providing, some of these new features that Angular is providing to help streamline our simplicity? Well, of course, number 1 is signals, right? And here's a simple class that I've written here, and there's essentially just 2 signals and 2 computed signals. And what I'm trying to demonstrate here is how we can get that integrity of data and how we can see how the propagation of change is really just done for us automatically, and we don't have to go ahead and mutate these data pieces. We're not reassigning them over the place. I think respecting that is really important in just creating better coding practices for ourselves. And so really what we're doing here is just in this first computed signal is defining the relationships between our data and declaring, right? We're being declarative over what goal we have for this new derived value. So in this case, we want to perform some calculation and assign the result of that expression to some new computed signal. The great thing is Angular is handing these dependencies for us and is propagating those changes automatically. So implementing signals is a huge win towards simplicity and enforcing good coding practices. To kind of bring home that extracting a function and embracing functions in our code, while this example is a little bit small and maybe not the best, it's probably overkill, but it was just more succinct to get the point across. So essentially, we could just extract some code into a function. Right now, it's super easy to unit test. I love unit testing little tiny functions like this for business logic that we might reuse all over the place. And then we have this little composable block of code that can be reused in other places. Strategy number 3 is to take measured steps and have steady progress. So it's not really just about making incremental changes, although that's great, but it's also about making those changes thoughtfully and consistently over time. Some of these strategies might be to start by focusing on small, isolated sections of your application. This way you could really gauge the effects of some new feature without risking the stability of your entire application. Keeping pull requests small and focused not only makes them easier to review, but minimizes the risk of introducing bugs. Prioritizing changes that offer the most significant benefits to our application. And also gradually integrating those so we could remain stable and not worry about updating every piece of our code all at once. So how does Angular help us with this? Basically, we have one option here, which is awesome, which is to use the interops, right? We can incrementally adopt with these interops because a lot of us already have observables, we already have a lot of existing code, and let's say we want to create this new class or component pricing page, and we see that a lot of this is very similar to what I've shown before, except now we're just assuming that the product price is coming from some service, and maybe it's really complicated and super long, and we're for this story that we're working on, that's a little bit out of scope. We're gonna limit the scope here, and we're going to just convert this to a signal, and we could see that all of the remaining code is still the same. So these are just really great tools for us to be able to slowly integrate and interopt the new signals with our existing code bases. Another good one is to utilize migrations for automatic code updates. So we have 2 here that I wanted to point out, which is to generate standalone components or to generate control flow. So standalone components, I think, really do decomplexify and simplify our development because it's helping to track the dependencies of what goes with what. If you've seen large modules where you have a bunch of components and a bunch of imports, and it's super difficult to determine which imports go with where, and it's hard to reuse it because you don't know exactly, oh, I need to pull this import out and that import out, and so using standalone just enforces that behavior. And also it's paving the way for us for lazy loading benefits of defer. Control flow, it just gives us a template conditioning language that we are used to because of JavaScript, and it's also improving the performance out of the box, right? They have the optimized tracking expressions to reduce that DOM manipulation. And so with these two little migrations, you could take your existing code, improve the simplicity, improve the performance, and it's a very small thing to do, right? We could do this as we're refactoring into new features. We always want to keep this mindset of refactoring is not something that we just decide to do for 3 days in a row. It's really something that's part of programming, right? We don't say that we're conditional writers, right? We're not refactorers. We're programmers and developers, and part of our job is to always just remain, attentive to, oh, what can I do here to make this a little bit better than it was? Strategy number 4 is to watch out for critters. What critters could I be talking about? Bugs, of course, is a big one, right? How can we test our code and have appropriate tests that cover the actual important stuff that our users care about? And how do we catch these user observable bugs before they land into production? So one thing is, I think becoming proficient at reading and writing tests is super important. I believe this kind of ties back to my first strategy of just to learn and become familiar with your tools. So, early in my career, testing was for sure the thing I was worst at. Every time I had to write a test, it was much longer than anything else I was doing, all this story or this task. And it became difficult for me to stay focused because it's just oh, what am I testing here? This seems like I'm not actually asserting on anything useful. And I got 100% test coverage, but there's still 14 bugs. And, it just hurt my soul a little bit. And so, when I shifted the mindset to testing user behavior, it not only made testing more enjoyable because I like building UIs, I like building things for users to interact with. So when I started approaching testing in that same mindset, it was oh, I know what to test here because what I'm building is they click the button and the form pops up and they fill the form out and they click, I could write a test for that. And so when you start testing on that, it also is helping keep the stability of our tests. So as we're updating these features, we're not just changing a bunch of the tests because that's not giving us the confidence that we need when we're doing an update, right? We don't want to be testing all these implementation details, and so every time we do change something, we have to change the tests, right? We want to have stable tests, ideally before we're doing some big refactor, and ideally before we do any kind of updates, especially some of these new features. So also, like I said, solely relying on code coverage can bite us, right? If we didn't take the time to properly reason about our code and understand what's happening, right, there's going to be an introduced risk. So also another big one here is to implement feature flags and toggles. This is a very powerful tool of just kind of an extra safety net for ourselves, whether our code's going into production and we're uh-oh, I need to revert that really quickly. It's nice to have the ability to do that. However, one tip that I've learned is that sometimes you can actually just increase a little bit of risk by implementing feature flags because I've mixed them in all over the place, and then when I go to remove them, it's risky to remove them, and I've actually removed something I wasn't supposed to. So one strategy I have is to really make clear boundaries when I'm introducing feature flags. We could do that at the route level with a can-match function, or just have big chunks of code that you kind of isolate. So sometimes I'll even leave comments. Delete this whole thing, delete these 4 tests, and it's really clear to remove later on, but also a really great safety net. The next little critter is a rabbit hole. That has been me many times, over and over, basically getting absorbed in a complex problem that starts from something small, but sometimes leads us far astray from our original task. And while rabbit holes are not inherently bad, right, a lot of times they're enjoyable and we learn a lot, but it's crucial to check in with yourself and be aware of if this is a valuable rabbit hole, you're falling down a rabbit hole and you land into a big thing of nachos with cheese and you're just man, this is so good. And then there's like most of the time, the rabbit holes I fall into are just like, it's like dark and I land into a pile of mud. I'm like, oh man, this sucks. And I come back and I don't learn anything. And right, so I think time blocking and striving for like specific and scoped goals are a great way to do this. So breaking down large tasks is also a good strategy here, right? We don't give ourselves too much room to go too far astray and lose track of time. Last strategy here is to elevate performance, right? We can elevate the performance of our applications by using many of the built-in Angular functionalities today. One of my favorite things that I like to leverage from the framework is using built-in directives like ng-optimized image. This is a really awesome way of just converting something like this, right? Like an image tag that we already have in our templates, and by adding 2 little pieces of code, right, we've just prioritized loading of our LCP image, right? And now all of our users, like, on different devices and different internet speeds, are getting the experience that we expect. Better yet, it gives us little things like hints for the developers ourselves that says, hey, you know what? The width wasn't quite right, or the height wasn't quite right, and it's going to potentially be distorted on certain screen sizes. So just doing this is like a very small change, and having the awareness of this as we're going through our code can really help just improve the overall user experience. What are some other things that we can do to leverage the framework? Well, optimize the speed of local builds with ESBuild and Vite, right? I think no developer likes to have like a slow workflow where every build and every refresh is taking really long. So just utilizing the newest features of Angular 17 are really going to help us get ahead on that. Also, leveraging the easy-to-use defer blocks to reduce our bundle sizes, making things load faster for our users, where if we've already used like a migration to update to standalone, and we're in control flow, well, now we can just add a defer block very easily, and now our users like aren't just dragging a bunch of stuff in the back end to load when we don't really need them to because it's below the fold or something like that. It's just really nice and easy ways to improve the overall performance of our applications. And sometimes elevating performance is not directly related to the code rewrite, but also in fostering a good environment to be able to do that. Right? We're humans that write the code for now, and I think it's very important to make sure that we just like elevate each other, right? Empower yourself and your team. Practice continuous learning. Keep exploring. Use the sandboxes if you want to. Get your hands dirty on some new features, right? Explore new ideas and approaches. Celebrate the successes of your teammates, right? Motivate everyone to strive for like incremental improvements, not just in the code, but in ourselves. And create a space where everyone feels comfortable sharing their thoughts, ideas, and concerns. I think being on a team where you're not afraid to ask a question because you don't want to seem like you don't know something, right, is a bad place to be, and I think it just like dampens down innovation. And especially right now, right, everyone should feel pretty empowered to be doing this because so many of these features are so new to us. So I think this is a big important point for me. The openness and like not only strengthens the team bonds, but just leads to like more collaboration and innovative solutions. Because basically, no matter how powerful the tools are and how amazing the tools are, like I said, we're humans writing this code, so we want to really make sure that we're in the best place mentally to keep moving forward and improving our projects. So that was my last tip, everybody. Thank you so much for listening today. It's been a pleasure sharing this with you. I hope you find some of these valuable. Yep.
All right. Yeah. Thank you, Anthony. I can confirm having a good team makes a big difference in your day-to-day, and you can kind of grow the team you want to be on. So remember that as you welcome new teammates, as you take on leadership roles. The next talk that we have today is one of our amazing sponsors. Raise your hand if you've been out to the sponsor tables in the hallway. Right? So remember, conferences don't happen without sponsors. And sponsors get to come when they interact with the people at the conference. So if you haven't taken a chance to go introduce yourself, find out what they're doing, sign up for some of the giveaways because they're giving away some pretty cool stuff, go ahead and do that. But without further ado, I would like to welcome our sponsor from ClickUp, Mr. John Lindquist.
Thanks. All right, hey everyone. I'm John Lindquist, the developer advocate for ClickUp. Now, ClickUp is the #1 productivity platform that's making tools like Jira, Notion, and others obsolete. ClickUp bundles task management, collaborative docs, GitHub integrations, time tracking, customizable dashboards, and much more into a single all-powerful platform. We even recently launched my favorite feature, our new ClickUp Brain, which integrates AI with all your data to help push productivity to the next level. You can stop by our booth for a demo. What makes ClickUp so special for this crowd is that ClickUp is the second largest Angular code base in the world, second only to those at Google. We've built from the ground up on Angular about 7 years ago, and now have over 100 Angular developers keeping updated with the latest version of Angular every step of the way. ClickUp is used by millions globally and by me personally. It's actually kind of nice to work on a productivity tool that I use for both work and my personal life. We have a very generous free forever plan, so you can just set up an account on the mobile app and start being more productive today. We're a 100% remote company with great pay, flexible vacation, and excellent benefits. So if you want to work with me or 100 developers who are much smarter than me, install our app, stop by our booth because we're hiring. Thank you.